Hi, my name is Brendan Bohan and I'm a Solutions Engineer here at SingleStore. Today we are continuing on with the mini-series of search tactics within SingleStore. In the second part we covered full text search, the search tactic that handles finding exact matches in large batches of text data. This episode is a fun one, semantic search in SingleStore. Semantic search is all too familiar in this day and age. Natural language processing, or the subset of AI that allows computers to understand, interpret, and generate human language, allows us to ask questions of our data and extract semantic information from it. Now, this is not to be confused with vector search, which we covered in the first part. Semantic search understands context and user intent using natural language processing. Vector search converts text into vectors in a multi-dimensional space, enabling retrieval based on similarity. While vector search aids semantic search by identifying relevant content, semantic search enhances this by using additional technologies for deeper insights, such as SingleStore. Okay, on to the actual implementation. This one is probably the most complicated out of all of the search tactics, as I am going to import a transformer to embed our simple text data. Let's get started. As always, you're going to want to navigate to the Data Studio on the left. And here there are two ways you can follow along. Create a new blank notebook or import the notebook from the description. I am going to import from a file on my local system. Click the Semantic Search Tactic notebook. Then click Import. Now that it is imported, let's run through it. Here we can see the hybrid ability of notebooks. We first pip install the Sentence Transformers package, import the necessary libraries, and a quick explanation of each. SingleStore DB allows us to connect to SingleStore, SQL Alchemy allows us to run SQL commands in Python cells, NumPy allows us to manipulate the embeddings, and of course, the Sentence Transformer package itself. We'll choose the type of model, in our case the model that maps the embeddings to a 384-dimensional vector space. We'll then insert some sample text data to vectorize. As you can see, I'm building a sort of restaurant review semantic search application. We'll next encode that array of documents. Then we'll check to make sure each encoding is of 384 dimensions. This will be helpful to know when creating the table. Speaking of creating a table, we will create a simple reviews table that holds the reviews embeddings, which are designated the vector data type with 384 dimensions. Next, just some quick setup to make sure we can run SQL magic in our cells. Here's where connecting to SingleStore is a breeze. In 4 lines of code, we can use the SingleStore package to connect to our database and execute queries all within one cell in one notebook. This one specifically inserts the documents text and documents embeddings alongside it. Now to the good part, the actual semantic search. So in vector search, we did something similar where we found the dot product, but we hadn't properly created relationships between the data. Here, we have proper encoding of both the documents and the query. Let's try with a less specific query. Give me fries. Not a great query when trying to find reviews, but I'm feeling lazy today. And the result is 0.39 relevance. Obviously, with less information, there is less strong of a relationship. Okay, great. Let's try again with a more specific query. I would like fries and a good ambiance with a friendly chef. We now see in the top 2 results a closer similarity. One with a chef who provides a good, adventurous ambiance, and in close second, crispy golden fries. Of course, if we had millions of vectors, if not billions, we would have a much higher similarity and more options to pick from. So, to end, this is a very basic example but shows the ability to generate embeddings, find similarities, and extract semantic meaning from your data. In the next video, we will work through our final search tactic, my favorite, hybrid search. Get creative, and as always, if you have any questions, feel free to speak with the team.